Hello everyone. Today I am going to talk about a very important topic which is called the enzyme kinetics. अब तुम लोग सोचोगे सर enzyme kinetics तो हमने biology में पढ़ा है. Definitely you studied in biology. Even if you have studied a small part of the kinetics in the kinetic chapter of class 12. लेकिन ये जो part है, this part is there in your surface chemistry chapter, but the question which actually comes combining the chemical kinetics with the surface chemistry. Okay, so today here what I will talk about in the enzyme kinetics part, exactly how enzyme works, but in little bit mathematical aspect we will talk about. चलो देखते हैं. इससे पहले सबसे हमें क्या जानना होगा? सबसे पहले हमें जानना होगा कि how does an enzymatic reaction works. Now definitely if we see in this way that enzyme is there, it is combining with a substrate. And what we know that it actually combines a enzyme substrate complex. So it forms an enzyme substrate complex. Enzyme substrate complex. Now again, if the substrate does not fit with the enzyme, it can revert back also. So remember, this step is the reversible step. The first step is the reversible step. And when enzyme substrate complex, it actually forms to the enzyme product complexes. Now, some of the group of scientists say that this step is also reversible, but for our simplification, we will not consider this step as a reversible step. Okay, now, so let's say this is your K1 and this is your K minus 1 and beta, this is your K2. And remember, this is the slowest step of the reaction, or this is called the RDS step of the reaction. This is your rate determining step of the reaction. Rate determining step. ठीक है, चले बेटा, what we can say from here then? We can say that the rate of the reaction is basically your dP by dt, the formation of this product in the dP by dt. चले basically is equal to what beta? K2 is equal to E into S, ES complex, correct? So this is my rate. Now beta, from here what we can tell? We can tell many things from here. Acha. Now if I consider the formation of ES, chalo, formation, let us consider the formation of enzyme substrate complex. Okay? Then what we can say that beta? We can say that DES by dt, this will be is equal to how much? This will be is equal to your K1 multiplied by enzyme and substrate complex, and since we were taking the initial concentration of enzyme as E0, so he will put a 0 here complex. Clear beta? Now next step. Now since this is the formation, then beta it is also what we can write then. Acha, here one thing. So if it is considered E0, so what we can write here, K1 into E0 minus ES complex, right? So ES into substrate S. Okay? Okay. Again, if I talk about the depletion, that is the formation and the depletion of enzyme substrate complex, tale minus of dE by dt is equal to what we can write, since it is depleted, so we can write K minus 1 into ES, and also my K2 into ES. Definitely, because it is going from, remember one thing better here, it is going from here also it is going and here also it is going. So basically both will be involved. But it is forming from K1, correct? Then it will be only getting from K1. Now if I talk about that using steady state approximation, or we can say that whatever rate the ES is forming, that is the same rate the E8 is depleting, then we can say beta, these two are the same quantities. These two are the same. Rate of depletion and rate of formation, they will be same. They will be definitely same. So if I use that logic, what we can say then? Chalo, let's rewrite the equation once again. So what we will get, data देखो, K1 into E0 minus ES multiplied by S is equal to what we can write, K minus 1 into ES plus K2 into ES. Okay, so we can write this one. So from here what we can say, beta, here what we can say, the enzyme substrate complex, if I do this one, so if I do, I will get ES is equal to, that I will get E0 multiplied by S, E0 multiplied by S multiplied by S divided by K minus 1 plus K2 divided by K1, okay, divided by K1 plus concentration of S. We can derive this equation. Now this part, if you can see very carefully, beta, this K1 plus K2 minus 1, this is known as Km. This is known as Km. And what is this Km? The Km is called Michaelis-Menten constant. The Km is called Michaelis-Menten constant. Menten constant, okay, which you will encounter several times when you talk about enzyme biology. You will encounter this Michaelis-Menten constant value several times. So what we can say here then? Then we can say the rate of the reaction, which was what? The rate of the reaction which was K2 into ES. So we will put the value of ES here. So क्या मिलेगा हमें? We will get K2 into E0 into S divided by Km plus S. Okay, Km plus S. Now beautiful equation. Now see here, there are two conditions are possible from here. This is a very, very important equation we can encounter from here. There two cases are possible. Now let's rewrite the equation once again. Tale rate is equal to what we can write? We can write K2 into E0 into S, Km plus S. Okay. Now two conditions we can get from here. In one case, your S is very, very, very greater than Km. That means for high substrate concentration, for high, I will write here, high substrate concentration. We can write, and another case we can write substrate is very, very, very lesser than Km, which is your low substrate concentration, which is for low substrate concentration. So what we can say from, if this is true, beta dekho, if this is true, then what we can write? Then we can write, if S is very, very greater than Km, then this plus this part will be almost equal to your delta S. Tale what we can write? The rate will be is equal to your K2 into E0. The rate will be is equal to K2 into E0. Here, if I talk about this K2 is called turnover number. This K2 is called turnover number, or it is denoted as K cat or turnover number. Okay. Now in this case, if I look at very, very carefully, then what we will get here? We will get R is equal to K2 by Km into E0 into S. We will get here. Okay, K2 by K0 into acha. Then what we can write here? If I rephrase this one, then I will get K2 into E0 is what? K2 into E0 is basically my K2 into E0. Acha. So what is this? This is known as the turnover number, and this K2 into E0, this term is known as V max. Now how we will get this one? Let me show you that. So we will write here V max by Km multiplied by the concentration of substrate. So basically if I plot, beta dekho, if I plot the concentration, versus the rate of the reaction, the plot what I will get? Here the plot what I will get will start from the 0, and after certain, when the concentration of substrate is high, it will be beta your parallel to the x-axis. Now beta, remember one thing, this thing is basically called your V max. When your substrate is saturated or very high concentration of substrate, we will get this value as your V max. Clear? Now there is a small last thing I want to tell here then. So what we got from here, we got R is equal to your K2 into E0 into S divided by देखो Km into your Km plus S. Okay, or what we can write, let's do this one, 1 by R is equal to what I will get then, 1, let's put this one as your V max, okay. Tale, what we will write here, we can write from here is that tale 1 by R, or 1 by R is equal to V max into S divided by Km plus S. Okay, now okay, or from here what we can write, 1 by R is equal to your Km plus concentration of S divided by V max multiplied by S, or 1 by R is equal to Km by V max into 1 by S into 1 by S plus 1 by V max. Now let's see, if I plot here the concentration of inverse of the substrate and the rate of the inverse of the rate of the reaction, what I will get here, very interestingly, if you see the graph, the graph which I will get, 1 by R versus 1 by S, if I plot concentration of S, so I will get starting from a point, so this will be y is equal to mx plus c kind of graph, right? That means it's a straight line with an intercept. So क्या होगा, यहाँ से हम देखेंगे कि intercept वाला सीधे straight यहाँ पे straight line होगा. And if I want to extrapolate this graph in this axis where the 1 by S value will be equal to 0, then your 1 by R value will be is equal to 0. In this case, then 1 by S will be here minus 1 by Km. The value will be here minus 1 by Km, and beta this value will be 1 by V max. This value will be 1 by V max. And if I want to make a plot this graph, the slope of this graph will be is equal to nothing but your Km by V max. Okay, now this graph is a very, very important graph. This graph is called line Weaver Bark plot. When we do the enzyme kinetics or enzymatic kinetics, we usually plot this graph, and from this graph actually we determine several quantities. We determine from here several quantities, like we determine the V max. Now if we can determine the V max, if we know the concentration of this enzyme concentration from the initial, from here we can easily calculate the turnover number. From here we can easily calculate the turnover number. Similarly, your Km value, this Km value, what it will give you? This will give you the overall kinetics, of the enzyme. This will talk about the overall kinetics of the enzyme. Remember always one thing, this will talk about the overall kinetics of the enzyme. So this is what the significance of V max and your Km value from this line Weaver Bark plot. Okay, and this was your all over the enzyme kinetics, that how exactly the enzyme works in our body when it undergoes a chemical reaction with the substrate. Okay, so fine everyone, hope you like this video, and if you like it, then obviously share with your friends, let them also know this topic. And definitely, if you have any comments or any kind of questions, feel free to write in the comment sections. Okay, so from my side, Dr. RGD, I am taking off. Bye everyone, take care, see you next time.